Tomorrow I have a meeting at district, so that means you will have a sub, but I always leave work for you to do in algebra and in here, and here's the work for in here. So this is exactly like the sub has a copy of these slides and everything. The sub has a copy of the seating chart of what you look like pictures and everything. So just keep that in mind. There were issues last time too, and I had to assign some detentions. So just keep that in mind. If you don't want to spend your after school with me, because I don't do lunch detentions, I make it inconvenient for you and your parents. If you want to spend after school with me, then that's fine. If you can't act right during the day, then spend time with me after school. But anyway, this is what you have to do. And normally I don't like leaving the day as like a makeup day. I always usually give you a task to do, but a lot of you have stuff that you need to make up. So this is what it says. Many of them have work to finish and or resubmit. They should do so in the following order of priority. So for example, the math lib, those were updated today. So whatever the grade is in Infinite Campus is your current grade. Those of you that are currently failing math lab, it's because of that. And really all you got to do is follow directions, redo it, resubmit it, and then it'll be updated when I have time to update it. But that's why you're failing, if that's an F for math lab right now. Then after that, you would have had the lesson 11 in algebra. You are working on completing that practice at 80% or higher. You get 2 attempts automatically. And I told you, like, I am working tomorrow. I will be on my computer. I can give you more attempts if you just email me. But 80% or higher is the threshold for that one. That one should be new to you tomorrow. So, like, it should already be done. Anyway, that's what your second task is. After that, it's making sure you have all your notes done for the binder check. I know not all of your teachers do binder checks, but majority of them do. And it's the note sheets that we do in class. So these notes, like you can help yourself to them, whichever one you're missing. I have video lessons for them all. If you need my YouTube and you're not in my algebra, just click on the links that are in here and it'll take you to my YouTube. But yeah, whatever lesson you miss, it is your job to make up. Like there's no way I could get you caught up in a 45-minute tutoring session on like 5 lessons. There's just no way. Everything you need to know is in the video lesson. That's why when you're absent, you have to make it up now on your own time. And you could use tomorrow's math lab class time to do that. But make sure your notes are up to date. You should have a note sheet for all the lessons from lesson 1 to now 10. And then you need to go back. This is like lower priority. Make sure everything else is done first. But make sure all your other assignments from algebra are 80% or higher. Because that I still need to update. That has been a while. And honestly, now there's so many of those like mastery assignments for math lab that I can't go back and spot check everyone to see if you actually ended up doing that homework. So if you want that grade updated for the mastery part, you need to send me a screenshot of your new score into the math lab link in Schoology. So there's that one. And then this is also what I'm leaving this up. I'm having them leave me a list of students who are using the hour as free time. So like I've told you before, if you finish everything you need to do, then sure, have some free time. But I want her to tell me who's doing that so that I can go back and check. Do they have all these things done? And if it's not, then I'm calling your parents. I'm telling them maybe math lab isn't a good thing. Maybe you need to go take like another PE class or something that we can squeeze you into. All right. So anyway, just letting you know, like not everyone that wants to be in math lab gets to be in it, but this is really a privilege to give you an elective credit while also helping you get the one that you need to graduate. So yeah, but today we did lesson 10, average rate of change, which we've seen before. So here's those objectives. You need to be able to calculate average rate of change for exponential functions. So when you hear the phrase average rate of change, what should you automatically be thinking of? Okay, perfect. If you didn't know that, some of you had algebra today, some of you still need to have algebra today. But if you don't know that, write it down now. That's what you would need for your practice. That's your average rate of change formula. So basically the difference in your outputs divided by the difference in your inputs. Now for exponential functions, it's a little bit different than for linear functions. For linear functions, we just called this slope, and the slope was the same throughout, no matter where you look. Now for exponential functions, and really any other functions in linear, you need to be able to calculate it over a specified period of time. They have to tell you for what intervals they want you to check, like from week 1 to week 3, or from year 0 to year 10. They have to tell you that, otherwise you can't actually calculate it. So you have to be able to read where they want you to look and then calculate it for that. Then, so let me give you a random example. Say that it wants it from week 3 to week 5. And it could be given in a graph, a table, a description, an equation. But you have to figure out, like for week 3, what's my output? For week 5, what's my output? To use that formula, you make one of your coordinates the x1, y1, and the other one the x2, y2. So this is how I labeled it. Table 2, what would my y2 be? The number for y2? 7. It'd be minus my y1, which is what, table 3? 4. Over my x2, table 5, what's my x2? Minus my x1, table 6, what's my x1? The way that I labeled it with my x1. Great. Do that, you could put this in Desmos from there if you wanted to, but if you're using just like any regular old calculator, I'd say put the numerator and denominator and parentheses like that. But then you work it out. So 7 minus 4 is 3. 5 minus 3 is 2. 3 divided by 2 is 1.5. That's my average rate of change. From week 3 to week 5, it changed by 1.5 on average. And it would have increased because it's positive. If you get an average rate of change that's negative, that means it decreased by that much. And that's really average rate of change in a nutshell. We'll do another example so I could show you that you have to look for a specified period of time. But we've done average rate of change before. Usually it feels a bit more comfortable than other lessons. So this will be what I want you to get 80% or higher on today. And make sure, like, when we do this, like when I tell you this is your goal for today, like since you're all here and present, that's what I told you accountable to. Like the people that are absent today, I will excuse the mastery part of it. I won't excuse the algebra part of it. You still got to do it. But I know that when you're gone, it takes a lot longer for you to catch up just in algebra. So I try to make it like more manageable by not making you, I don't know, get 80% or higher on it necessarily. So keep that in mind. Like always do like what today's task is, or like the math lib, since that's like the assessment. If you still need to redo that, maybe prioritize that. But always do the task for the days that you're here. You'll notice I excused them for the ones that are not here. But anyway, I said I'd do one more example for those that haven't had algebra yet today. Okay. So any problem that asks you for average rate of change. So here's a situation. Nelson took a summer job for 5 weeks where he received a weekly salary plus tips. His take-home pay is recorded in the table to the right. What's the average rate of change in his weekly take-home pay over the 5 weeks of his job? So you have to read it for where to look in that table so that you can use your average rate of change formula. So table 7, can you remind me what my average rate of change formula is? Okay, good. Table 8, can you tell me where this problem wants me to look in the table? Like what time frame does it want me to calculate it for? Okay, so this one is significant. What other week is significant? Okay, good. Because it said, what's his take-home pay over the first 5 weeks of his job? So I need this coordinate and that coordinate. We could have said from week 1 to week 3, and then I'd use that coordinate instead of this one. Could have said week 2 to week 4. You just gotta pay attention. Once you've identified the coordinates you need, whether it's from a graph, table, whatever, you make one of them x1, y1, the other one x2, y2, and plug it into your formula. So then my numerator then is going to be 80 minus 60, y2 minus y1, over 5 minus 1, x2 minus x1. Cohen, what will this simplify to? You don't have to tell me the final answer. You just tell me like fraction. Good. So 80 minus 60 is 20, 5 minus 1 is 4. Simplify it to either a decimal or a whole number. That's usually what we ask you to put it in. So table 2, what's 20 divided by 4? 5. So the average rate of change from week 1 to week 5 was $5 per week. Is that necessarily what it changed by each week? Not all the time, but it's the average. That's what we call it, average rate of change. Okay, so I'll leave this up as an example, but of course, if you need more examples, you need a little bit more help, just call me over and I'll help you. If the task today is less than 10, I'll pass back the math libs that were graded and I need to pass back. You only need to resubmit it if you do more, which some of you should. Check that grade in Infinite Campus and see if you also, if you did help with lesson 10, number 4, then we're going over that one. So, and of course, yours might be shuffled if you're in a different class, but this is the one we're looking at from lesson 10. So the function F gives the number of copies a book has sold W weeks after it was published. Here's an equation that defines this function. And then it says select all domains for which the average rate of change could be a good measure for the number of books sold. So domain means what? So domain and range are different. They're like in the same subject, but different. Domain specifically refers to all the what in a function. All the x's, good. So Dr. XY is a good way to remember which is which. Domain is all the x's, or other words, inputs. In this situation, what is my input representing? Or what letter are they using for the input in this one? They're using W. W is for weeks. This one's asking for what number of weeks would it be a good measure the average rate of change? So for that, let me take you back to the notes, and I know some of you haven't had it yet, but here's a main topic. When we did the activity today, we calculated a bunch of average rates of change, and we did it for 3 weeks, 6 weeks, and 10 weeks. So if you compare, like this straight line would be what we calculated for the average rate of change. The dots are our actual data. So if you look at the really long line, does this long line touch many of the data points? So that would be not a good measure of the data. To say that each year it increased by 140 is not really a good measure for the data, even though that's the average rate of change. If you look at like the first 3 weeks, that smaller line, all right, I don't know if you can see it, but I'm pointing to it. You see how this little line touches all those dots? See it? That was a good fit. And remember, line's the best fit, touch almost all the data points. So when it's a smaller time frame, that will give you a better measure, because we know that for exponential functions, they change at a really fast rate. So the smaller time frames would give you a better measure. So remember that. When we relate it back to this situation, this is representing 0 to 2 weeks. So really like 0, 1, 2, we're looking at a span of 3 weeks. 0 to 7 weeks is a span of 8 weeks. 5 to 7 weeks, so 5, 6, 7 is a span of 3 weeks. 5 to 10 weeks is a span of 6 weeks. And 0 to 10 weeks is a span of 11 weeks. We know that the smaller time frames give us better measures. So which two, or I guess it's a select all, but which ones would give us the best measure? Are you with me so far? If we know that the smaller time frames give us the best measurements, then which one should I pick? Like the third option and the first option? Okay. And of course, it can be shuffled on your screen. But the reason it's these ones is because each of these have a span of 3 weeks, whereas the other ones, it's a much longer time frame. All right, so that's why I wouldn't want to use those average rate of change values as much as these two. Okay. Questions on that? Questions on others? Yes, sure. Lesson 8, in case you guys also needed help with number 1 on lesson 8. But for an experiment, a scientist designs a can 20 centimeters in height that can hold water. A tube is installed at the bottom of the can, allowing water to drain out. At the beginning of the experiment, the can is full. When it starts, the water begins to drain, and the height of the water in the can increases by a factor of 1/3 each minute. And we repeat the following and explain why the height of the water in the can is a function of time. So anytime there is blank, one corresponding value for water height. So remember about functions, what makes something a function? Anyone can answer this. What makes it a function? Okay, what's different? What's the correct expression, and mine has the expression. Either way, you should be able to make the expression though, because it does give you enough information. And let's see, it says it's decreasing by a factor, so that should tell you that it's exponential. It does tell you your starting amount is 20. It tells you what it's decreasing by, which remember when we times, it's by what remains, not by what it's losing. So if it's decreasing, well, actually, let me take that back. It did use the phrase factor of 1/3, so that is what we're going to multiply by. For a second, I thought it said it's losing 1/3. Since it's factor, that is what we multiply by. So then when I go back to that one, that's why it should be this expression. That's how you can get the answer. Is that all you needed help with on that one? Okay. Anyone else need help on this one? Otherwise, we don't need to necessarily go through it. Okay, she had a question on number 4, and then we'll come back to you. So this is number 4 on lesson 8, right? Well, what does it say? Okay, so yeah, I ended up deleting that on mine because technically it could be yes or no, depending on how you think about it. So, but my algebra students don't have that one, but so you could say yes, and then in your answer, you say whether it is or is not a function depending on that explanation, and then the other explanation is like the reverse. Like, so you could say yes or no, depending on like think about that one. That's why I'm looking at it. Okay, question. Okay, or no? Okay, anyone else have a question from any of those unit 5 stuff? You said number 4? Okay, so which graph shows the graph of f? Oh, is it related to like the question before it? I don't have any other information. Okay. Okay, yeah, it's related to this one, I think. Function f gives the number of stray cats. So let me write it down so I have it. 243 times 1/3 of t. And we want the graph that goes with this, assuming it's the same setup. So we want one that starts at 243, and it is exponential since it's that exponential setup. Right? It looks like, I don't know, we wait this next minute. But it looks like this format, the equation. So then it should definitely not be the first one that's on my screen, because that would be a linear function. So definitely don't pick the ones that are linear. So that completely eliminates A and B on mine. It's between C and D. Now, we have our starting amount, which what's another name for starting amount? Your A, or like on a graph, where would it be your starting amount? Not necessarily. Your y-intercept. So where x is 0. So which one looks like it's at a y-intercept of 243? Then you pick this one. Okay. We might have time for another question. Yeah. Number 6. This one, right? Okay. So which shows the graph of G and the domain and range of G? So I need to go back to the previous to get the equations. Give me a second. I don't like when they split them up, but I can't, I don't want to go back and change it, so I'm just going with it. But here's the equation. And we have to see what it represents. Domain stands for what? No, domain refers to all the what in a function? The x's. So use the, guys, stop talking. I can't hear myself. So domain refers to all the x's. Use this like way to memorize it, Dr. XY. Domain is all the x's. Where my x's would normally go is here. So see what the t is representing in this. It'll usually tell you. T is going to be hours. So we would need to pick a reasonable possible hours. So let me go back to number 6 now that I have the info. Okay, so for which one shows the graph of G? Well, this one starts at 600, so that looks like a good sign. This one doesn't, so don't pick the one that doesn't start at 600. This one starts at 600, that one doesn't. So we're between 2 answers now. So for C, it says the domain is all non-negative numbers. The range, which is milligrams of medicine, is all positive numbers less than 800. Does that sound like an appropriate range? If it starts at 600, then it can't necessarily be 700 or 800, can it? So then I wouldn't pick C. Let me go make sure that A is right. I don't see a domain and range description for A. Oh, are they all right below it? Yeah, let me right above that one. Let me read this one. Domain is all positive numbers less than 600. Okay, that's wrong. Because domain is for the x's. So then domain is all non-negative numbers. Range is all positive numbers less than 600. That makes sense. Okay. So make sure you guys use this time wisely.